In 2010, a group of scientists put a dead fish into an MRI machine. That salmon changed the face of neuroscience as we know it. Want to know how? Keep watching to find out. Have you ever just been minding your business on the internet and then come across an article that said something along the lines of, I'm a neuroscientist and then it starts making these crazy or outrageous claims? So my dad and I have this little game that we'll like to play where he sends me some of those articles and then I tell him as a neuroscientist how much of those I think are actually helpful. And these titles range from things like, I'm a neuroscientist and here's why I believe in manifestation, which, harmless, interesting, simplified but within reason, to I'm a neuroscientist and here's the truth about TikTok brain rot, to my favorite piece of science communication in the world, which is I'm a neuroscientist and I wear a bike helmet. 10 out of 10, no notes, perfect. Wear a helmet, you guys, actually, that's safe. But the thing about pop neuroscience is that it's not just limited to neuroscientists trying to explain their own work to a mildly interested public. It's the power of these neuroscience buzzwords that I want to talk about today. So have you ever heard of a dopamine detox? This was a trend that started on LinkedIn, and it's basically limiting yourself from doing anything fun to reset your behaviors and curb your dopamine addiction. Guys, this is like trying to hold your breath to curb your oxygen addiction. It does nothing and it won't solve any problems that you actually have. Do you want to know what happens when you don't have enough dopamine? You actually stop a lot of habits, including breathing, because you die. So this reflects a misunderstanding of neuroscience, biology, and psychology all rolled up into one viral LinkedIn trend. I think a perfect example of a neuroscience buzzword that we've all heard about is neuroplasticity. So neuroplasticity is the innate ability that your brain has to change. Connections can be strengthened or weakened, and entire parts of the brain can grow. An example of this that you may have heard of is a study that was done on London cab drivers that found that they actually have larger hippocampuses, and this correlates with how long they've been driving. So your hippocampus is your part of the brain that is responsible for maintaining and creating mental maps and memories. And this makes sense. London cab drivers have to have very extensive knowledge of the greater area of London. So it makes sense that they have a really strong part of the brain responsible for maintaining those mental maps. Personally, I love the hippocampus. It's a very recognizable part of the brain. So thank you for that. This leads us to an issue, however, when regular people get a hold of that study and then start thinking to themselves, oh no, is my hippocampus a little small? So this has led to all of these apps and websites designed to be brain gyms that can train your brain. And you really don't need to do that. Unless you're suffering from some kind of medical or psychological condition, your brain is working fine for your life. You are wired correctly. If you want to change your behavior, you don't need a dopamine detox or a brain gym. You can just try changing your behavior. I think this culminates with biohacking, the group of people who treat the body like a machine that you can hack. So what do intermittent fasting, light therapy, and high-intensity interval training have in common? Biohackers love them. People into biohacking want to optimize some aspect of their lives, their health, their well-being, their productivity, and they choose to do this in a very physical way. This can range from benign and normal interventions like improving your diet and exercise routines to straight up sci-fi stuff with tech implants. And a fairly normal thing in the biohacking space is to take like 50 unproven supplements. I mean, I have genuinely read the phrase, "Do you even magnesium, bro?" And I'm not sure if the poster knew whether or not they were being sarcastic. And supplements really are biohacking's bread and butter, but not actual bread because sugar will kill you. The thing about supplements is that they're mostly unregulated. So the FDA chooses not to regulate supplements beyond being reasonably safe. This means that supplements don't actually have to help in the way that they say they do. Supplements can also change the way they affect you based on how you ingest them. So with food, without food, if they're a pill form, the pill versus an IV form can have very different physiological effects. You also may or may not even be deficient in something in the first place. And then beyond that, the supplement itself may or may not be pure. So what this adds up to is that in the best cases of supplements going wrong, you have expensive pee. You're releasing the supplements that don't do anything to you because you're not actually deficient in that nutrient. The worst case is that you end up consuming something really, really harmful because it was just packaged in that supplement and no one bothered to do lab testing on it. I think that the favorite words of a bad supplement salesman are, "No, bro, you can't take that. That has chemicals. But my stuff is fine." So why am I talking about biohacking and supplements in a video about the dangers of bad neuroscience communication? And when will that fish thing make sense? Well, to get there, we have to start with one of biohacking's top voices, neuroscientist Andrew Huberman. So Andrew Huberman is the neuroscientist who made science interesting again. He is a professor of neurobiology and ophthalmology at Stanford, and he has a really, really popular podcast that covers everything from healing from PTSD to improving skin health and everything in between. And I don't hate him. I think that Huberman is a really talented communicator. He's really good at breaking down complex topics for a lay audience or a non-expert audience. And I have a whole video about how important I think that science communication is. So obviously I support that. And I think that if you listen to his show and you feel like you get something out of it, that is fantastic. So I have a couple issues with Dr. Huberman, but I'll start with my issue with philosophically the body as a machine that you can optimize. So one of the things that Huberman is known for is having these protocols governing what you should eat, how to sleep, how to work out, and how to stay motivated. And a lot of this advice is fine. Lowering your alcohol intake, for instance, is a great piece of advice. Alcohol is a carcinogen, which means it's associated with cancer. And I think that that's a good piece of advice to give out to the general population. But then he'll do things like invite sunscreen and fluoride skeptics onto his podcast. And then his claims in general are just mixed with this wild misinformation that I think that the average person is unlikely to spot. An immunologist did a whole 4-part newsletter about the inaccuracies contained within a few of his episodes. These range from using bad studies to making claims with little to no evidence supporting them, including flu vaccine skepticism. And misinformation aside, I just feel like you can't use neuroscience like a Bible because it boils this cutting-edge research down into something prescriptive when in reality neuroscientists are trying to be descriptive of the science in front of them. So I listened to an episode of Huberman's podcast to make this video because I will do anything for you, my dear sweet viewers. I listened to the episode Improve Focus with Behavioral Tools and Medication for ADHD. And overall, I came out of it actually kind of liking Huberman a bit more. He's a likable guy. He's charismatic. He's really good at breaking complex topics down for a general audience. And I think it was interesting. However, I did get the impression that the expert that he brings on kind of makes the episode, especially if Huberman himself isn't a pure topic expert in what they're talking about. What I mean by this is that sometimes Huberman would kind of just spitball an idea that he had been having about his own personal experiences with having potentially ADHD. And then the psychiatrist, which we had on the show, would occasionally push back against those ideas and kind of be like, okay, well, what you're saying might hold some weight for you, but I don't know if it would apply to everyone. So I think that having a reasonable and measured expert is really, really important in that kind of context. I also took a little bit of issue with the ad reads that Huberman was doing. Since it is a podcast about explaining science to the general public, and Huberman himself does sometimes make medical recommendations, the ad reads themselves, which tended to have a bit of like science-y words in them, could sound like recommendations, and I think that that should just be a bit more clarified in general. One of the bigger issues that I have with Andrew Huberman is the platforming of pseudoscience in quacks. And I guess you could ask whether it's a sin or an inevitability of popularity. But I just said that the expert makes the show, and Huberman is known for having people like Jordan Peterson, who is trying to make sexism cool again in the psychology world, onto the show. And the sheer volume of content that Huberman puts out means that sometimes he has to say something wrong or misinterpreted, which is fine. That's human. I just take issue with him selling it all as science. His whole brand is wrapped up in science. So he has his protocols, which are very reminiscent of the lab protocols that I would read from when I was doing an experiment. He calls the podcast Huberman Lab, which makes it sound like he's discussing his own lab results. Some of his episodes are journal club episodes, which is what we do in the lab. Like we read an article from a journal and then talk about it. And it's enough, honestly, to kind of turn off real scientists because it just feels like work again. But it seems so official and scientific to the general audience, which I think can really mislead people. And the thing is, this is not a hit piece on Dr. Huberman, okay? I think that he's a great science communicator. I think he's got really interesting stuff. It's just a bit sad that he's the rock star of neuroscientist. And again, it's quite difficult not to fall into the dangers of bad science communication with that much content coming out. I mean, he does like at least 1 3-hour episode a week, so that's a lot of content. And his website does say that they welcome constructive criticism, so it seems like he's at least willing to hear if he did get something wrong. But the overall practices just seem a bit predatory or a bit too close to predatory for me. I mean, gosh, guys, it's inevitable that even I'll say something wrong just over the course of this channel. And I'm pretty sure I already have, for example, in my Does the Brain Mature at age 25 video, I put up that graph, which is incorrect. I wrote growth. I really should have written like total volume or something of the brain. So saying misleading things is kind of inevitable if you have like a certain amount of content that you put out, because we are human and we make mistakes. But yeah, it just feels a bit predatory. And again, I do feel like so much of neuroscience, we tend to read it as prescriptive when those studies are really truly descriptive. So what do I mean by that? So that leads me to part 2 of this video, which is, can we even neuroscientifically say that? So I am here to give you an insider's take into the limitations of modern neuroscience. I did my master's degree in neuroscience not that long ago and my undergrad in neuroscience, so I'm pretty familiar with the field. And so 2 big tools that are really, really important in modern neuroscience just to examine the brains of live humans are EEG and fMRI. They have given us so much insight into how parts of the brain respond to situations and inputs, and they've been really helpful in identifying neural correlates, is what they're called, of specific functions in humans. So you've probably seen like a piece in the New York Times, like "This is your brain on love," and it shows a picture of the brain and it's got color in certain areas, and that part is active when you're in love. And those are usually fMRI studies, and they will give us a lot of information about what area of the brain is active during certain processes. And I've learned a lot from lecturers that specialize in both of these techniques. The issue is that science is slow, and one very interesting study can't really say much beyond that thing is interesting, because we as scientists need a body of research before we can start to make conclusions. So one of the challenges of fMRI that we were still working out pretty recently is accurately identifying real changes in neural activation. And this takes us to the dead fish problem. So, like I've already said, before 2010, a group of scientists put a dead salmon into an MRI machine. And that fish changed the face of neuroscience as we know it. Why? Let me briefly explain fMRI to you. So you may have had an MRI scan before. You'll put a body part into an MRI scanner, they'll scan it, and you'll get a picture. fMRI is a bunch of those pictures taken really, really quickly. And we can use that to find out what parts of the brain are active. We do this by taking really, really detailed pictures, because MRI, or magnetic resonance imaging, works by looking at the natural magnetic resonance of your blood and tissue. Fortunately, your blood has iron in it, and we can actually look at MRIs to see what areas of the brain are using more activity or using more of that blood. So yeah, fMRI shows the functioning of the brain. It's really cool. So a few years ago, some scientists were trying to set up just a normal fMRI experiment where they were going to scan some participants and ask them questions and see what happened in their brain. And they decided just while they were setting up the machine to run it on a dead salmon, just literally like a fish from the grocery store, to make sure that everything in the machine was calibrated properly. They wanted to be able to look at the structures of the salmon and make sure they could see everything really well. A few years later, one of the scientists wanted to run a seminar on properly running MRI experiments. So they decided to carry out those statistical tests on the salmon. And the thing is, what he found was that the salmon had shown different brain activation when answering the questions. Now, this is an issue because the salmon was dead. So how did this happen? The thing you have to know about statistics is that brains are big. And when we do any kind of statistics, we have a chance of finding something that isn't there. This is the same type of error as getting like a false positive on your COVID test, as in you don't actually have COVID, you're perfectly fine, or maybe you have the flu, and then your test still shows a positive, which is wrong. And fortunately, we have ways to mathematically correct for this. This makes it much harder to get any kind of positive results, but it also makes it much harder to get any false positive results. And like I said, that uncorrected salmon, so the salmon where they were just doing a ton of statistics, showed some statistically significant brain activation, which is an issue because it was dead. So this pushed neuroscientists to use those corrected statistics a lot more. This led to improved use of those corrected statistics, meaning that we're a lot less likely to find a positive result, but we're a lot less likely also to find a false positive result. So this is good. That dead salmon did really change neuroscience as we know it, but it still illustrates the kind of problems that we were trying to solve as late as 2010. Zombie fish aside, we also have some other general issues in neuroscience to worry about. So there is the replication crisis. And you remember how I was saying that false positives happen sometimes in research where your statistics will show you a difference that might not be there? Unfortunately, those types of errors are more likely to get published because we love it as scientists when an experiment shows something. This has led to something of a crisis because a lot of big studies can't be replicated. Fortunately, we are getting a lot better at publishing studies that don't have that issue to start with. So we are slowly working through that. There's also the challenge of linking changes in the brain with changes in behavior. This isn't a crisis, it just takes a lot of time for all that research to happen. And finally, there are the general challenges of translational research. So just because something works in a rat or a mouse doesn't mean that it will or won't work in a human. So does this mean that science is bad and we're all doomed to ignorance forever? No, of course not. So what does a trustworthy study look like? And actually, this is kind of a trick question because I, as a scientist, want to see studies, plural, that look at similar things and find similar results. And lots of preliminary studies can have small sample sizes and kind of shaky methods, especially if they were done in the 50s, for things that we now consider facts. So an example of this is place cells and the hippocampus. I have already told you that the hippocampus is responsible for maintaining a mental map of your surroundings. And one of the first ways that we actually found that out was by finding place cells. So these are actual neurons in your hippocampus that will light up whenever you go into a specific place in a room. And the original study that found this out was, honestly, it had a super small sample size and it didn't look at that many neurons. But over time, we've added so much more research to that study that we now can say for a fact that the hippocampus is responsible for those mental maps. So what this means is that it's okay to have a small preliminary study if we can build a body of research surrounding it that will maybe change a couple things and find similar results and then change some more things and then find new results. So we're constantly updating our understanding of the research. But wait. What if that research was all done on animals? Can we make conclusions about how humans will react to something? And the answer to that is no, especially if you're looking at something like a drug or a substance that will change something going on in your brain. You need a drug development pipeline. So the drug development pipeline will take a molecule all the way from the very beginning of drug discovery all the way through preclinical development, clinical studies, and drug approval. And this will start with tons and tons of possible molecules that will just get narrowed down over and over and over until we arrive at one drug that does the thing that we want it to do. And then we will test that in animals, and then we'll test that in humans, and we'll see if it actually has any side effects and whether it solves the problem that we want it to solve. And then after a drug does all of those things and goes through all those processes, it'll get approved. And after it's approved, it'll go through a post-marketing surveillance period where we'll monitor it over time to make sure that there are no bad side effects. So here's a big problem. Supplements do not go through this process. This means that if a substance is good and well tested, it is probably an actual drug, not a supplement. So if neuroscience has some issues with it, and if the science tends to describe things rather than prescribe things, and if you need a whole drug development pipeline to figure any of this out anyway, then why can't we get enough pop neuroscience? What's the fundamental issue here? And I would argue that we are looking at a bad case of neuro-essentialism. So I'll explain what that means in a minute, but I'll start with a confession. I was pretty into psychology in high school. I did end up majoring in neuroscience for my undergrad, and the reason that I chose neuroscience over psychology when it came time to choose was that I wanted to learn things that seemed more concrete, more real than how psychology felt at the time. In retrospect, I'm really glad that I chose neuroscience. I did end up falling in love with it, but that reasoning was pretty shaky. But this idea is widely held by members of the public and neuroscientists alike. And it's the idea that everything that you need to understand psychology is within the brain, and the only thing that you need to look at is the brain. So how can neuro-essentialism lead us astray? I think that it's important to understand that some psychological conditions and phenomena can and should be understood in a psychological lens, and that the pop neuroscience isn't necessary or helpful. So, for example, a few months ago, my husband and I made a bet. I told him to switch us to decaf without telling me because I was convinced that I had no idea there was a difference between decaf and regular coffee. And aside from a little headache of withdrawal, which I assumed was from the weather, I really didn't notice the difference. The coffee I was drinking still woke me up. This is a perfect example of the placebo effect, which I can explain through a psychological lens. Neuroscientifically speaking, I have no idea how that worked, and I don't need to because I have a perfectly good psychological explanation right in front of me. Or for those of you who need a metaphor, and most of this does come from a paper by Schultz in 2018, which I will link as with all of my resources in the description below. But imagine that you handed a physicist a dollar bill. This physicist could analyze every atom and particle within the bill, but that still wouldn't give the physicist any information about the value of said bill, because that information is contained externally to the bill within society. And I think that a lot of the neuroscience questions that we're trying to ask might be contained externally to the brain and maybe at the unit of the group or people. So, are you interested in changing your habits, becoming more productive, changing your behaviors overall? That is psychology. That is the brain putting things into action. You can try CBT. You don't need a dopamine detox. So why do we need to listen to pop neuroscience so much when psychology is right there and maybe some other disciplines could help us better understand the world around us in less confusing ways? And I think this leads back to our desire for an objective and fact-based understanding of ourselves. But honestly, some issues and behaviors can be explained using psychology. And for these issues, it is unlikely that we will ever have the computational power to explain them purely on a neurological basis. I mean, do you know how hard it is to model everything, like neurologically speaking, that goes on in a lobster's digestive system? And that's the simple version. And I think that the bigger issue at play here is scientific literacy. Determining what good science or what a good explanation is can be really, really hard. Science and pseudoscience can sound so similar. And that leads us to part 3. Who is wrong here anyway? Or why am I expecting you guys to be science literate? So what is science to you? Does science appear every day in your life? Or are you most interested in it when it affects you personally? Because for many people, the challenges and things that you learn in your personal life will add meaning to the formal knowledge that you acquired in school or in your daily life. And eventually, any new knowledge that you pick up will be woven into your personal experience. And that's not a bad thing. But I think that our experiences during COVID and other issues that have been popping up these days have shown us that we also need a degree of scientific literacy that's not just limited to our daily experience. We need to be able to judge what science is, which can help us navigate a changing world. So I ask again, is science relevant to you? Because the kinds of science that you are likely to engage in are the kinds that affect you personally. This means results. A gym bro probably isn't going to care how a study was done or how it arrived at that conclusion as long as it helps him get gains. And it is so human to believe, especially when someone starts telling you scientific words and giving you scientific advice. We want to have a cheat code to life. The thing that Huberman and biohackers understand is that science is useless to the average person until it isn't. We want a prescription, and we're so much less interested in the details. But even when science is relevant, even when science starts affecting our health, we can't all know everything, even me. And that's why we have to have those trustworthy experts like scientists and doctors. And that's where I start taking issue with pop neuroscience communication. Because the scary thing is when those trustworthy experts stop being trustworthy. When someone is trying to sell you a supplement rather than give you good advice, people like Dr. Oz, people occasionally like Dr. Huberman, it starts eroding public trust in those institutions, and that is dangerous. So where do we get advice? Personally, when I want health advice that is for the public, I go to the NHS. I Google something and I add NHS at the end and I read their advice because they are trustworthy to me. But I do think that we are at a lack for public science communicators that use their platform responsibly. And I think that's a problem. So what am I trying to say here? I think what I'm trying to say boils down to that neuroscience is cool, but it's not the only discipline that can give you insight into yourself. And we as scientists have to learn how to communicate about things that people are interested in. But we as members of the public also have to get more skeptical when someone tries to sell us something or solve all of our problems and starts using words that we don't understand. Scientific literacy can be held at the community level. Don't be afraid to start a conversation with an expert or a scientist or a friend and see where it takes you. It's okay to learn things. So what are my final thoughts here? I think that it's okay to want advice, but be skeptical when someone is trying to sell you something that only they have. Neuroscience is so cool, but if someone is trying to teach you how to hack your brain, they're probably just trying to hack your wallet. So thank you so much for sticking with me on this one. I know that it was a long one, but I hope that you feel a bit more equipped to deal with the wild world of pop neuroscience communicators. And just generally evaluate a message before you believe it wholeheartedly. And if they're trying to sell you something, especially if that something is an untested supplement, be skeptical. So thank you for watching so much. I am just thankful for all of you, and stay curious.